Hello guys, welcome to the course Inorganic Made Easy. So to make the study of inorganic chemistry easy, we are putting up this course, and today in this series we are going to discuss the thermal decomposition of various salts and acids. Thermal means heat and decomposition means breakdown. So we are going to learn how these various salts and acids they break down when we are going to heat them. This is going to be part 2 from the thermal decomposition reactions. We already discussed about the thermal decomposition of metal carbonates, metal bicarbonates and metal hydroxides in the previous lecture. In case you have not watched that, please do check out our playlist and do watch that lecture also for a complete understanding. We are also put that in the link above in the suggested videos, so you can just click over there as well and watch that lecture. Now, today we are going to discuss the thermal decomposition of ammonium salts. Now, why are these thermal decomposition reactions important? In the last lecture, I showed you a question. This is a question from JEE Mains 2012. And the question says, which of the following on thermal decomposition yield a basic as well as an acidic oxide? So you need to know the thermal decomposition of all four of these. And apart from that, you have to learn about the thermal decomposition of many more ionic compounds. All of these, they are ionic compounds. They are built up of cations and anions. So many cations possible for various metals, and the ammonium ions are also going to be cations. So lot many cations we can have and lot many anions we can have, and a combination of all of them is going to give us a large number of compounds. First of all, writing down the large number of compounds and then learning about the decomposition reactions of those is going to be a tedious task. So here we at H2O chemistry are going to help you in understanding that very easily, how you can remember so many reactions, and this is going to be really very helpful to you, because if you look at any previous year paper, be it JEE Mains, Advanced or NEET, you will be finding at least one question or at least a choice from that question where you have to tell the product of a thermal decomposition reaction. So that is how you are going to learn it. And as you can see, one of the choices over here is ammonium nitrate. So ammonium nitrate on decomposition, what is it going to give? And when there are going to be more different anions associated with this ammonium cation, what are going to be the products formed? So that is what we will be learning in this lecture. I am Dr. Ritu Johar, your educator from the channel H2O, the A to Z of chemistry, and I hope you're going to enjoy your learning with me. So please be ready with your paper, sorry, not paper, your notebooks and your pen, because you have to write all of this and remember this for your examination. So for all of those who have not watched the lecture on thermal decomposition of metal carbonates, bicarbonates and hydroxides, let us quickly revise what was thermal decomposition reaction. How do we define it? So thermal decomposition reactions are going to be those reactions where a compound is going to break down on heating, forming two or more products. For example, we have lithium nitrate. When we are going to heat it, it is going to give us lithium oxide, nitrogen, dioxide gas, and along with that oxygen. So here we have lithium nitrate. So this is a metal nitrate and we are heating it. So this is going to be again one type of thermal decomposition reactions that we will be learning, where what is going to be the product on the heating of a metal nitrate we will be learning. Right? So all these I'm going to be teaching you in a few lectures so that you can have a very good understanding. Now, please do remember, when we say a decomposition reaction, there is going to be only one reactant. Okay, as we see over here, we have one reactant, that is lithium nitrate. And because these are decomposition reactions, we are trying to break down the bonds present in between the atoms of this compound. So we have to supply energy to break those bonds. Therefore, energy supplied means these are always going to be endothermic reactions. Reactions where heat has to be supplied. And when we say thermal decomposition reactions, this means that this energy that has to be supplied is going to be in the form of heat. So now we come up to our discussion for today, the thermal decomposition of ammonium salts. What are going to be the products formed? Let us see a few reactions. We have, for example, the heating of ammonium carbonate. So we have learnt about the carbonates, the bicarbonates and the hydroxides in the last lecture, but those were metal carbonates, metal bicarbonates and metal hydroxides. What is going to be the product when the carbonate, the bicarbonate or the hydroxide is going to be an ammonium compound? So ammonium carbonate on heating, this gives us ammonia, along with that water and along with that carbon dioxide gas is evolved. Then we have ammonium bicarbonate. This on heating gives us ammonia, water and carbon dioxide, same products being formed. And then we have ammonium hydroxide giving us ammonia and water, right? So what do you think? In all of these, you can see one common thing, that ammonia is being formed from the ammonium ion. So what does this mean? Does this mean that all ammonium salts on heating, they are going to yield ammonia? Well, the answer is no. For example, let me show you two more reactions. First reaction, the heating of ammonium dichromate, NH4 twice Cr2O7. On heating, this is going to give us N2 gas along with that water and along with that Cr2O3. Now, another reaction, let us see that we have ammonium nitrate. On heating, this is going to give us N2O gas and along with that water. So you can see different types of products, they are being formed on heating of a ammonium salt. So otherwise, if I do not give you some way to remember these, well, it is going to be very difficult to remember the product, right? So how are we going to learn these? Let us understand that. So what we will be doing to understand what is going to be the product form is looking back at these reactions in a greater detail. Let us look at one example, that was ammonium carbonate on heating giving us ammonia, water and carbon dioxide. So here, please do write down what is the oxidation number of nitrogen in ammonium carbonate as well as in ammonia. Well, it is going to be -3 in both the cases. In the ammonium ion also and ammonia, both nitrogen is in -3 oxidation state. So what this means is, in this reaction, there has been no change in the oxidation state of nitrogen. But if you look at this one example, we have ammonium dichromate on heating giving us nitrogen, water and Cr2O3. Here you will be seeing that the oxidation number of nitrogen in ammonium dichromate is -3, whereas in nitrogen it is 0. So here there is a change in oxidation state from -3 to 0. An increase in oxidation number means there is oxidation of nitrogen taking place. Now what is causing this change in the oxidation state of nitrogen? Well, there is no other thing apart from this one reactant that we have. So it is change in the oxidation state of the cation taking place, and that is going to be by the anion. For example, in the Cr2O7 minus, the dichromate ion, this is causing the change in the oxidation state of nitrogen from ammonium ion to nitrogen, and the carbonate ion is not causing the oxidation of nitrogen from ammonium ion to NH3. So there is no change in oxidation. So what this means is that if we understand these anions in a better detail, well, we are going to very easily learn the products that are going to be formed. Let me explain you how. So what we will be doing is, a trick to remember the product is going to be the anion. We are going to classify the anions into two types. One are going to be the oxidizing anions, which are going to cause a change in the oxidation state of nitrogen, and one are going to be the non-oxidizing anions or weak oxidizing anions, which do not cause a change in the oxidation number of nitrogen. For example, we have the oxidizing anions 2BnO2 minus, NO3 minus, MnO4 minus, Cr2O7 minus, ClO4 minus, IO3 minus. So these are the 6 oxidizing anions that you have to learn for these ammonium salts. Apart from these, all the anions that we will be having, for example, the carbonate ion, the bicarbonate ion, OH negatives, SO4 2 negative, PO4 3 negative, iodide ion, chloride ion, bromide ion, the halides that we will be having. So all of these, they are going to be categorized into the non-oxidizing anions. When these anions are going to be present, there is not going to be a change in oxidation number of nitrogen, right? So what will happen is when we have an ammonium salt, of the ammonium ions with any of these oxidizing anions, the product, one of the products is going to be definitely nitrogen. There is going to be release of nitrogen gas with the exception of the nitrate ion, which is not going to release nitrogen, but it will be releasing N2O. All right. And then the non-oxidizing anions, when they will be present in the salt with the ammonium ions, the product that we will be getting is ammonia gas, right? So I think it is going to be very easy if you just remember these 6 anions. These 6 anions, the product is going to be N2, and even the nitrate ion, if you just remember it is going to be N2, the way I'm going to teach you to write down the products, you will ultimately get this N2O also. All right. So these are the oxidizing anions and these are the non-oxidizing anions. So let us see now how the products are going to be formed. So now let us learn first of all the thermal decomposition of ammonium salts containing oxidizing anions. Alright, so how are we going to learn the product which is going to be formed by the thermal decomposition of, for example, ammonium dichromate? Right? So I do not want you to mug up the products that are going to be formed. I am making your study easy by giving you an understanding how to write the products without mugging up the reaction. So first of all, what you have to do is identify which is the anion that is present. So Cr2O7 negative, this is an oxidizing anion, and when it is an oxidizing anion, it is going to release N2. So this is one thing that you have to remember, the 6 oxidizing anions. So Cr2O7 negative, the dichromate ion, this is an oxidizing anion, and when it is an oxidizing anion, it is going to release nitrogen gas. This is the only thing that you have to remember for writing down the products of this reaction. Okay. Now, first of all, you have got this N2. Now, what are the remaining products that are going to be formed? So, if you see N2, this means from ammonium dichromate, we had 2 nitrogen atoms, which we have taken out. From the remaining, what you have to do is you have to see how many hydrogens they are present. So, this is going to be H4 into 2, that means 8 hydrogen atoms. 8 hydrogen atoms can give us how many water molecules? Well, it is going to be 8 divided by 2. That will be 4, because in each water molecule there are going to be 2 hydrogens present. So count the number of hydrogen, divide that by 2 and convert these into that many number of water molecules. So ammonium dichromate, the second product that will be formed, are going to be 4 water molecules. All right. So now 4 water molecules means that 4 oxygen also have been used from ammonium dichromate. So nitrogen gone, hydrogen gone. What is remaining behind? Just count that. So what is it? It is going to be 2 chromium atoms that is going to be left, and there will be 3 oxygen atoms that will be left. Simply just write them together and you will be getting the product Cr2O3. So what is going to be the final product of this reaction? Ammonium dichromate on heating is going to give us nitrogen gas, 4 water molecules plus Cr2O3. Isn't it easy now? Yes, it is. Let us see one more example. The next example is NH4NO2 ammonium nitrite. So what are going to be the products formed? Let us see that. First of all, we see what is the anion. This is NO2 negative. So this is also an oxidizing anion. And when we have an oxidizing anion, what is going to be one of the products? It is going to be nitrogen gas. So you have written nitrogen. So next step, what is it going to be? Two nitrogen gone. You have to see how many hydrogen atoms there are present. So there are 4 hydrogen, means there are going to be 2 water molecules that will be formed. And after the formation of 2 water molecules, all the atoms, they are finished in this. So this means this is the final product of this reaction. Ammonium nitrite on heating will give us N2O, and along with that 2 water molecules. Let us look at one more example. I think this should be very easy. So again, NO3 negative is the anion. This is an oxidizing anion. So one of the products, we write it as nitrogen, and then we are going to count out how many hydrogens they are present. So hydrogens, there are 4 in number, so we will be getting 2 water. After that, you will be saying what is left. What is left is going to be just 1 oxygen atom. So that 1 oxygen atom, just put it with again N2. So this will be giving us N2O. So this was the only exception from the oxidizing anions where nitrogen gas was not released. It was N2O that is getting released. So this is also very easy to remember. No problem in learning it. Great. So now let us see one more example. NH4ClO4. What are going to be the products formed? And I would like you to pause the video here and first of all try writing down the products yourself. So if you've done that, let us see how we are going to do it. First of all, ClO4 negative is the anion. This is an oxidizing anion. So there is going to be release of nitrogen, but nitrogen is N2, and here we have just 1 atom of nitrogen. So simply multiply this by 2. So we will be having 2 molecules of NH4ClO4. All right, so we evolve nitrogen from here. Now next step is going to be seeing how many hydrogens present. So it is going to be 2 into 4, 8 hydrogens. That means 4 water molecules, and remaining what is going to be left is 2 chlorines and 4 oxygens. Now what is going to be the product that is going to be formed? This is different from what you have already learned. What we have learned was we are just going to write this together. And writing this together would mean Cl2O4. But that is not what is the product form. So please do remember a small little trick over here. If the leftover atoms, they have a metal, write all the atoms left together to form an ionic compound as we did for Cr2O3. But when these remaining atoms, they do not have a metal, all of them, they are non-metals, then you are going to write them down separately. So what this means is 2 chlorine atoms are going to give us 1 chlorine molecule, and 4 oxygen atoms will be giving us 2 oxygen molecules, right? So the total product is going to be NH4Cl4 giving us nitrogen, water, chlorine and oxygen. So now I think all the oxidizing anions with the ammonium cations, the salt formed, and you have to heat them, the product that are going to be formed should be very clear. You do not have to mug them up, but you know the product which is going to be coming in your examination. So if I ask you NH4IO3, the product that will be formed is N2 plus water plus I2 plus oxygen. So next, let us learn the thermal decomposition of ammonium salts containing weak or non-oxidizing anions. All the anions apart from the 6 we have learned as the oxidizing anions. For example, we have to heat ammonium carbonate. What is the product that will be formed? So again, we identify what type of anion the carbonate ion is. So carbonate ion, this is non-oxidizing in nature. So definitely what is going to be the product that will be formed? It will be ammonia gas that is going to be released. So oxidizing, it is nitrogen, and non-oxidizing, it is going to be ammonia. So one product we know for sure, the heating of ammonium carbonate, this is going to give us ammonia, but along with that carbon dioxide and water are also going to be evolved. So how are we going to remember these products now? Do we have to mug them up? No, not at all. Then what are we going to do? Well, we are going to follow a very simple trick. And the trick is replace the ammonium ions with H positive to form the corresponding acid. What this means is ammonium carbonate on heating, this is going to give us 2 ammonia, and along with that it is going to give us H2CO3. Okay, so we had 2 nitrogens, corresponding to that we have 2 ammonia, and then what we did was simply replace the ammonium ions by H positive, so that became H2CO3. So this is now what you have, and then what you are going to do is this acid, we are going to dehydrate it, remove water molecules from that corresponding to the number of hydrogens. So when you are going to heat H2CO3, 2 hydrogen means 1 water molecule gone out, and what will be remaining behind is carbon dioxide. So this is going to be the products that will be formed on the thermal decomposition of ammonium carbonate, ammonia, carbon dioxide and water. So now let us see a few more examples for the non-oxidizing anions so that this becomes perfect in your mind. The next we have is the heating of ammonium sulfate. So ammonium sulfate, when we are going to heat sulfate ion, this is a non-oxidizing anion. So ammonia is going to be released. So 2 nitrogen, so we have 2 ammonia, and then because we had 2 ammonium ions, we will be replacing this by 2 H positive ions. What you will be getting is H2SO4. H2SO4, again you are going to heat it further, and you are going to remove the hydrogen present here as water molecules. So H2 and 1 oxygen is going to go out, and what will be left behind is SO3. So the final product for the heating of ammonium sulfate is going to be 2NH3 plus water plus SO3. Easy enough, I think. And the next we have is ammonium phosphate. Ammonium phosphate, we have 3 nitrogen, so 3 ammonia going out, right? Then we replace the ammonium ions by H positive. What will acid become? H3PO4. So we written that H3PO4, we are going to heat it. What is going to be the product form? We have to remove water molecules. So when we are going to remove 3 hydrogen, means that you just remove 2 hydrogens as 1 water molecule. What is going to be done? Water, and along with that what will be remaining will HPO3. Now HPO3 again has hydrogen, so again we are going to heat it and get another product. But now 1 hydrogen obviously cannot go, so you will be multiplying this by a 2. So that will make it H2P2O6, and then we will be again removing 1 water molecule, and what we will be getting is P2O5. So the final product for this reaction, the thermal decomposition of ammonium phosphate, will give us ammonia, water and P2O5. I think now it is going to be very simple for you to write down the products. Just you do not have to mug them up. You have to understand what is happening. And then we have ammonium hydroxide. You are going to again heat it. First of all, ammonia goes out. Ammonia goes out. What will be left behind? Or you can say we had 1 ammonium ion, so we replace that by a hydrogen. And what we will be getting is HOH. That means nothing but water. So NH3 per water is going to be the product. And then we have NH4Cl, again Cl, so non-oxidizing, so again NH3 going out, and then the ammonium ion, we replace it by a hydrogen, so what we will be getting is HCl. Easy enough. I do not think that you will get it wrong ever. But now what we need is to attempt the questions which come in the examination. So let us see a few questions, what type of questions they are coming and how we are going to perfectly attempt them. So let us look at question number 1. Question number 1 says we have NH4NO2 on heating. This gives us A and H2O. NH4NO3 on heating. This gives us B and H2O. What are A and B? Are both of them nitrogen? Are both of them N2O? A is N2O and B is N2. A is N2 and B is N2O. So I think now this should be very easy for you people. We've already done it. So just try it first of all yourself. So if you've done it, let us look. First of all, NH4NO2. NO2 was an oxidizing anion. So it was releasing nitrogen. After that, how many hydrogens? That gave us 2 water molecules and nothing was left. So N2 plus water, whereas in case of NO3, there will be one oxygen left which we added on to nitrogen. So we got it as N2O plus water. So the correct option is therefore going to be D choice. A is N2 and B is N2O. Easy enough now, I think. The next question is, among the following compounds which on heating do not produce N2 gas? Ammonium dichromate, NH4Cl plus NaNO2, NH4Cl plus calcium hydroxide CaOH whole twice, and barium azide BaN3 twice. Alright, so how are we going to do this? Let me explain you that, because certain reactions you will be saying that we have not learned in this lecture. So first of all, the reaction number 1 you already know. Ammonium dichromates, we have Cr2O7, 2 negative, 2B an oxidizing anion. So nitrogen will be formed along with that. How many hydrogen? 8 hydrogen, so 4 water, and what will be left behind will be Cr2O3. So that is the product that will be formed for reaction number 1. Alright, reaction number 2, we have NH4Cl plus NaNO2. This is a double decomposition reaction. Just switch over the anions for the cations, right? So we will be getting NH4 NO2 and NaCl as the product that will be formed, but we are heating it. Sodium chloride is going to be stable, but NH4NO2, again on heating, this will be forming N2 plus water the way we learned it. So this is an oxidizing anion. So nitrogen gas will be relieved. The remaining we are going to put up as water, and sodium chloride was the product formed by the double displacement reaction. So these are the 3 products that are going to be formed. Similarly, you can do it for reaction number 3. Just switch over for the double displacement. From NH4Cl and calcium hydroxide, you will be getting NH4OH plus calcium chloride. Again, on heating, NH4OH, OH is going to be a non-oxidizing anion. So the product will be ammonia gas, along with that water, and along with that calcium chloride. So these are the 3 products that are formed. And the 4th one, which you have not learned, this is one of the preparatory reaction for nitrogen. You learn this all reactions when you will be learning the preparation of nitrogen p block element group number 15. So this is again a very important reaction. There we get the purest form of nitrogen by heating of the azides of group 1, group 2. For example, barium azide, this is going to give on heating barium and nitrogen gas. So the question, what did it say? Which of the following do not produce nitrogen? So you can see there is only one choice where we do not have nitrogen gas being produced, and that is going to be C choice, right? So only one reaction more that we have to learn, and this is very important as far as nitrogen preparation is concerned. So please do learn this. Next, we have a very similar question that was asked for the JEE Mains 2018 examination. The compound that does not produce N2 gas by thermal decomposition is, and now this should be very easy because the 4th choice I've already told you in the last question, and the rest 3 you already know. So Cr2O7, 2 negative, this is going to be oxidizing anion, nitrogen gas will be produced. Sulfate ion, non-oxidizing, nitrogen gas will not be produced. NO2 oxidizing, again N2 gas will be produced, and barium azide, nitrogen gas will be produced. So the correct option is going to be B choice. So now let us see question number 5, the question which you saw at the start of the lecture. Which of the following on thermal decomposition yield a basic as well as an acidic oxide? And the choices now, we do not know the thermal decomposition of the nitrate ion. This we will be doing in the next lecture. Alright, then we have KClO3, again the chlorate ion, not learned till now. Alright, we will be doing it still in the upcoming lectures. The carbonate ion decomposition we've already learned, and the ammonium ions we have learned in this lecture. So these are the 2 choices you can now do yourself. So First of all, we have the correct option to be the C option, which I've already told in the last lecture, that calcium carbonate on decomposition is going to give us calcium oxide and carbon dioxide. Calcium oxide is a basic oxide, carbon dioxide is an acidic oxide, and this is what was required of the question. And then we have D choice, which we've learned this lecture, ammonium nitrate on heating. This will be giving us N2O and along with that water, right? So this is what we have as far as these two choices learned. Upcoming lectures, we will be learning more of these. So we come to the end of this lecture where I am leaving you with one question as a homework. Question is on heating. Compound A gives a gas B, which is a constituent of air. This gas, when treated with hydrogen in the presence of a catalyst, give another gas C, which is basic in nature. A should not be. And this is the JEE Main September 2020 question. The options are number 1, ammonium dichromate. Then we have ammonium nitrite, we have lead nitrate, and we have sodium azide. So ammonium dichromate, you know what is the answer on heating, what it is going to give. Then ammonium nitrite also you have learned. Lead nitrate, because we will be learning about the metal nitrates in the next lecture. So we will be discussing the solution to this in the next lecture. And sodium azide is going to be just like we did barium azide in one of the questions. So do try it, and then we will be discussing in the next lecture. You can put your answer in the comment section. I will be really very happy. So that would be all for this lecture. See you again for the next. We are going to discuss thermal decomposition of the metal nitrates. So please be with me to subscribe to the channel so that you get the notification the moment I put up the next lecture for you. See you again. Have a nice day. God bless you.